Let's talk about the chemistry of alcohols. First, we'll go through how we prepare alcohols. One way of preparing alcohols is by hydrating an alkyne, in which we do so by adding dilute sulfuric acid. Or we can break it down into two steps. We can add concentrated sulfuric acid, and as a second step we can add water, in which case the hydroxide will bind to the more stable the carbon that produces the more stable carbocation, while the hydrogen binds to the other carbon. Here the carbons are more or less the same, so we don't have to worry about that. But if we if we for example have a ethyl group over here instead of a methyl group, that would be the more stable carbocation, and that would be the carbon to which the hydroxide group will be added. And this is one way of producing an alcohol. By adding Bayer's reagent, basically aqueous permanganate solution, into an alkyne, we get what we call a vicinal diol, which looks as follows, where hydroxide groups are bound to the two carbons that are bound by a double bond. Another way of producing alcohols is by adding aqueous KOH, or aqueous metal hydroxides, into a alkyl halide, in which case the halide will be replaced with a hydroxide group and thus producing an alcohol. Another way of producing alcohols is by reducing carbonyl compounds. Here we have either a aldehyde or a ketone, and what happens is if we were to add a reducing agent, the carbonyl group will be converted into a carbon attached to a hydroxide group. In other words, an alcohol. One way of doing, we can use these reducing agents. We can use we can add lithium aluminium hydride dry ether and then add water, and we can get this. Or we can use NaBH for methanol and then add water, and then we can also get this. Or we can use alternative, these are less popular reagents, but we can use sodium and ethanol, or we can use H2NiPTO/PD. Ideally, use lithium aluminium hydride dry ether water, and less ideally sodium borohydride methanol and water instead of these two. And that's how we can reduce carbonyl compounds into alcohols. Another way of producing an alcohol is by having a carbonyl compound, and we can add a Grignard reagent as the first step and hydrolyze it with acidic water, in which case the alkyl group of the Grignard reagent will add to the carbonyl compound, carbonyl carbon, as follows, and this carbonyl group will be converted into a hydroxide group by this step. We can also reduce carboxylic acids into alcohols as well, using the same reducing reagents that we have discussed over here. Yeah, carboxylic acid into alcohol. Another thing we can do is by doing this same Grignard reagent acidic water thing, but with an acid halide instead of a carbonyl group, in which case the alkyl group bound to the of the Grignard reagent will be added twice into the carbon, even replacing the halide, and we will see that this group will be converted into a hydroxide group and producing this compound as a byproduct. Another way of producing alcohols. Another way is by adding nitrous acid into amine. Here we have ethylamine, and we add nitrous acid into it, and it forms ethanol and evolves nitrogen and water as byproducts. Here we can't exactly, the nitrous acid is very unstable, so we on the spot we mix sodium nitrite with hydrochloric acid, and it will form the nitrous acid. Another way of obtaining an alcohol is by doing the same Grignard reagent uh, acidic water process to an ester, and just like the acid halide, we will get a similar product where the alkyl group of the Grignard reagent is added twice to the carbonyl carbon. Even this methoxide group is like it disappears, and the carbonyl group becomes a hydroxide group. And these are how we prepare alcohols. Now let's talk about how alcohols react. Well, one thing we can do, here are some interesting reactions of alcohols. Alcohols, they react with sodium to produce alkoxide ions, but they do not react with sodium hydroxide because alcohols are not acidic enough. Methanol is an exception, it is a bit acidic, but in general, alcohols, they don't react with sodium with bases like sodium hydroxide. And and and, and another way alcohols are not acidic enough is we can't add carbonates or hydrogen carbonates and observe the evolution of carbon dioxide gas. We can react alcohols with carboxylic acids under concentrated sulfuric acid medium, and it can reversibly form the respective ester. Here we have ethanol, which will contribute to this ethoxide group over here, and we have ethanoic acid, which will contribute to this group over here. These two bound by a ester bond and producing water as well. Another thing we can do to alcohols is undergo halogenation to produce the respective alkyl halides. We can heat an alcohol with PCl3 or PCl5 or SOCl2, and we can get alkyl chloride. We can heat alcohol with hydrogen bromide or PBr3 or red phosphorus with bromine, and we can get the respective uh, alkyl bromide. And we can do the same thing with hydrogen iodide heated or PI3 heated or red phosphorus and iodine heated, and we can get the respective alkyl iodide from the alcohol. Another way of another reaction we can do to alcohols is by adding Lucas reagent into it. Basically, this is the Lucas test, in which we add Lucas reagent, anhydrous zinc chloride, and concentrated hydrogen chloride, concentrated hydrochloric acid. This is a way of differentiating between primary, secondary, and tertiary alcohols. Actually, with primary, secondary, and tertiary alcohols, because they all form the respective alkyl chloride at the end of the day, and produces a white color turbidity, but based on the time it takes to form that turbidity, we can determine which alcohol is used. If a quick turbidity is formed almost instantly, what we have is a tertiary alcohol. If it's not instant but takes a bit of time but not too long, what we have is a secondary alcohol with two alkyl groups attached to the carbon. If we have a primary alcohol, it will take a very long time to produce that turbidity, and that's the Lucas test. Another thing we can do is add acidic potassium permanganate, or basically acidic we can oxidize alcohols in an acidic medium to produce the respective carboxylic acid. But what if we want to obtain a carbonyl compound or in specifically an aldehyde from this primary alcohol? You can only obtain aldehydes from primary alcohols. Both of these require oxidation, but for this we can use a less stronger oxidizing agent. For that we use PCC, pyridinium chlorochromate. Pyridinium chlorochromate. Here we can't here like carboxylic acids are not formed when secondary or tertiary alcohols or secondary alcohols are reacted with acidic oxidizing agent, in which case it will produce only the ketone. Yeah, it's only the ketone, only the ketone is producible. Tertiary alcohols cannot be oxidized because like what can it be oxidized into? We can also undergo something called the iodoform test to alcohols, but we don't exactly have it in the syllabus at the moment. And these are the chemistry of alcohols.